In this video, I'll show you how to do a two-sample z-test. So it's for when we have two independent samples and we're testing the difference in the means, and we're assuming that we know the population standard deviations. So this example is a department store, and we've recorded samples on the mean, on the age of customers who shop at an inner city store and customers who shop at a suburban store. So at the inner city store, we have 36 customers with a sample mean age of 40, and we're assuming that the population standard deviation is 9. In the other sample, for the suburban store, we have 49 customers, and our sample mean age is 35, and we're assuming the population standard deviation is 10. The standard error combines the two standard deviations using the sample sizes, and 2.07 is the standard error. The test statistic is a z-test statistic because we're assuming we know the population standard deviation, so we're using the normal distribution. And it's the difference in the sample means, 40 minus 35, divided by the standard error. And I've got a -0 in here, and that's because in this hypothesis test, we're testing whether the difference in the means is 0 for the null hypothesis, versus the difference in the means is not 0 in the alternative hypothesis. We can test other values other than 0, but just to remind ourselves that we're testing for a 0 difference, I've got -0 in here. And we're doing a two-tailed test here. So we have a not equal sign in the alternative hypothesis. Our p-value, so we're doing a two-tailed test. So it's going to be the sum of the tail areas to the right of 2.41 and to the left of -2.41. And because the normal distribution is symmetric about 0, that's the same as 2 times the tail area to the right of 2.41. And that's what this formula is doing. It's multiplying 2 times, and then 1 minus norm.dist of 2.41 is the tail area to the right of 2.41, because norm.dist just by itself is the area to the left. So that's why we've got 1 minus here. So there's our p-value. Let's do alpha equal 0.05 test, so significance level 5%. Usual rejection criteria. Reject the null hypothesis if the p-value is less than the significance level. And it is in this case, so we reject the null hypothesis. So this suggests that there is a difference in the means. Alternatively, we could use the critical value from a normal distribution, and for a 5% test, two-tail test, the critical value is 1.96. And the question to ask is, does the test statistic lie either to the right of plus 1.96 or to the left of minus 1.96, because it's a two-tail test. It lies to the right of 1.96, so it's in the right-hand tail, the upper rejection region. So we reject the null hypothesis. So whether you use the p-value or the critical value, you'll reach the same conclusion, rejecting the null in this case. We could also calculate a confidence interval here. So confidence is related to the significance level. So 5% significance level, 95% confidence. Margin of error is that critical value times the standard error. And then the lower bound of the confidence interval is the difference in the means, which is 5, plus that margin of error, minus that margin of error. So 5 minus 4.06 comes to 0.94, and then the upper bound is the difference in the means, 5 plus 4.06, so 9.06. So we're 95% confident that the difference in the population means is between 0.94 and 9.06. Let's do another example. So here we have exam scores at 2 different testing centers. Sample size of 30. In the first sample, mean of 82. We're assuming the population standard deviation is 10. Sample size of 40 in the second sample, mean of 78. Assumed sample standard deviation of 10. Standard error combines those 2 standard deviations and makes an adjustment for the sample sizes and comes up with 2.42 for the standard error. Test statistic is difference in the means divided by the standard error, comes to 1.66. P-value for a 2-tail test is the sum of the tail areas beyond 1.66 and minus 1.66, comes to 0.0977 in this example. If we're doing a alpha equal 0.05 test, the p-value is bigger than 0.05, so we do not reject the null hypothesis. There's not enough evidence here to reject the null in favor of the alternative. The critical value, 1.96 as usual for a 5% significance level 2-tail test, and 1.66 is not in the rejection region. It's not less than minus 1.96, it's not bigger than plus 1.96, it's in between. So it's not in the rejection region. So again, that would tell us that we cannot reject the null hypothesis. The confidence interval, the 95% confidence interval in this case, margin of error is 4.73. So the lower bound goes from 82 minus 78 comes to 4. 4 minus 4.73, which is minus 0.73, and 4 plus 4.73 is 8.73. So we're 95% confident that the population difference in means goes between minus 0.73 and 8.73. So you'll see that 0 is in that interval. That's why we couldn't rule out 0 with the hypothesis test. An upper tail version. Let's have a look at that. All this is the same, all the way up to the test statistic. What's different is the p-value. Now, because we're doing an upper tail test, the p-value is simply the area in the upper tail. So the area under the normal curve to the right of 1.66, and it's half of the 2-tail p-value, so it's 0.0488. Interestingly, it's less than 0.05, so for an upper tail test here, we would reject the null hypothesis. And also, if we use the critical value method, you can see that the critical value is only 1.64, but the test statistic is 1.66. It's just barely into the rejection region, but that's enough to reject the null hypothesis. Okay, let's see how XLStat does a 2-sample Z-test. And let's do a 2-tail test and see if we can match the numbers that we calculated by hand. So 2-sample Z-test, there we go. Let's pick our data. So exam scores. Let's make sure we get all the data here. And then again, make sure we get all the data. Oops, that didn't work. Let's try that again. There we go. We'll do a Z-test. And under options, let's see, we were going to do a 2-tail test, weren't we? 2-tail test, hypothesized difference is 0, 5% significance level. And then variances for the z-test. We're assuming we know what they are, and we were assuming 100 for the variances. Remember, we assumed 10 for the standard deviation, so the variances must be 100. And we'll OK that. And oh, that's really big. Doesn't need to be that big. Okay, here we go. Let's see if we got the same numbers. 1.656 for our test statistic. Two-tailed test. So let's see what that third decimal place is. 1.656. Yes, we matched. 1.96 is the critical value. P-value, 0.098. Well, let's go to one more decimal place, 0.0977. If we go up here, 0.0977, I think that's what we got to. Yeah, 0.0977. So there we go. And the decision, again, as the computed p-value is greater than the significance level, we cannot reject the null hypothesis. So for a two-tailed test here, we can't rule out that the population difference in means is 0. And we can also see that from the confidence interval going from minus 0.734 up to 8.733. 0 is in that interval. And what did we get for our interval? Well, let's go one more decimal place, if we match exactly. Yes, we do. Excellent. Okay, so there we go. That's two-sample z-test, two-sample normal test when we've got two independent samples.